You're live. I'm live. We're live. Welcome. Good morning, good afternoon, good evening. DJ here. Not with hands-on SAP Dev this time, of course, because it's a Monday afternoon. I mean, who live streams on a Monday afternoon? Here in Manchester, sunny Manchester. Anyway, if you've joined for the SAP Community Coding Challenge number 2, you're in the right place. So welcome. Thanks, everybody, for joining. Yeah, it's going to be a little bit different to my normal live streams, which is sort of quite exciting. In this particular live stream, what I wanted to do with you all is just explore, well, first I'll give you an update about the coding challenge itself and explore some of the amazing solutions that you've sent in. So let's get going. I mean, we've got all the time that we need, really. One of the weird things is that I'm starting this live stream knowing, I'm going to turn this TV up actually, knowing that, it's not fixed to an hour. My hands-on SAP Dev solution live streams are always an hour, which I try to do. But, if we need less than an hour, if we need longer than an hour, it's all good. Hey, Morton, oh, hi. Oh, hi. And Domi, hi. Raul, hi there. Lars, Max. Public holiday greetings to Germany too as well. Yes. So welcome. Yeah. So as you know, currently we have an SAP Community Coding Challenge on the go. The first one was an ABAP-based one, and this one, of course, is a JavaScript-based one. And we can see, hopefully, on the, there, on the screen in front of us, we've got a blog post, which you may have seen before, but I'll post the URL here as well with a little bit of an update. So the deadline was sort of middle of last month, and yeah, there's been a ton of submissions. We've had around about 80. Some of you folks have submitted multiple solutions, which has been really interesting, really, really nice. Lots of different styles. One of the really nice things about JavaScript, of course, is that it's a multi-paradigm language anyway. So, that it sort of lends itself to, self-expression and expression in different styles, which is great. Some really, really cool solutions. So I thought I'd spend the next however long it takes to have a look at some of those. Not all of them, of course. I would love to show you all of them. But, we've got to draw lines somewhere. So I've got a list. But before we continue, let's have a quick reminder of what the actual challenge was. So when we start to look at the code, we can have a look. We can sort of contextualize our brain to understand what that code is trying to do. We're not going to look at in huge detail, in microscopic detail at the code because we'd be here all day. But basically, the Collatz conjecture, in fact, the Collatz conjecture itself, the code is based upon a sequence relating to the Collatz conjecture. It's an unsolved problem in maths. Does the Collatz sequence eventually reach 1 for all positive integers initial values? Okay. And if we look at the challenge here, the challenge was from the Project Euler website, a fantastic website with lots of lovely maths puzzle challenges. Hey, Deepak. Hey, Napit, Johan. Good afternoon, good morning, good evening to you all. Welcome as well. So the challenge is defined as follows in this little screenshot here. Hey, Mahesh. Hi, 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 hi. The following iterative sequence is defined for the set of positive integers. So basically, this is the Collatz sequence. If n is even, then you divide n by 2 to get to the next term in the sequence. And if n is odd, then you multiply n by 3 and add 1. Okay, so starting at a given number, you follow this pair of rules. And in theory, this is what the conjecture is all about. In theory, that regardless of what number you start at, it will eventually end up with the value 1. Okay, so if taking this rule here, taking these two rules here, and we start with this example number 13, there are 10 terms. 13 is odd, so 3 times 13 plus 1 is 40. 40 is even, so divide 40 by 2 to get 20. 20 is even, divide 2 by 2. Oh, yeah, we're getting closer and closer to 1, but oh my goodness me, 5 is odd, so we go back up again. You know, oh, we're moving away from one again. So this is the beautiful thing to think about in this conjecture. And the problem statement was, and there's a few submissions that sort of fixated upon this example here, right? But the problem statement is which starting number under 1 million. Some of you also include, I mean, not that it made a difference in the actual final calculation, but some of you submitted a solution which actually looked at 1 million as well, which I thought, you know, nice but no cigar. But anyway, who cares? Which starting number under 1 million produces the longest chain? Okay, so, you know, taking the longest to meander all the way back down, up and down, up and down, up and down, all the way back to 1. Okay, so like I say, there's been some amazing solutions. So why don't we just dive in by looking at a few of them? I've picked out, I think, 19 or 20, which, you know, I would love to show them all, like I say. And there's, you know, but this is the smallest number I could pick. So if you don't appear here on this live stream, if your solution isn't here, it doesn't mean to say it's no good. It's just that, you know, we have time restrictions. So let's get rid of that and get rid of that. And the way I've done it is I've organized it into a series of folders. I want to start with Dommy's here, okay, because here's Dominic Beale. And I think, Dommy, did I see you on the stream? Welcome if you are. Welcome if you're not and you're watching the recording. So I'm not quite sure what this about me is all about. I quite like it, you know, a bit of binary there, a bit of hex. That could be a puzzle in itself. Maybe we need to solve that to learn a little bit more about Dommy. But anyway, I wanted to point out Dommy's solution because one of the wonderful things, I think Dommy was the only person to specify this. It's in a comment as well. Okay, it says here, I mean, the wonderful thing is that he submitted a solution. Let's run it anyway while we're waiting. Submit a solution in 3 different ways, or 2.5 different ways. Okay, but the really cool thing is that he says here the solution relies on the correctness of the Collatz conjecture. So basically, yeah, we're all assuming that the Collatz conjecture is true, i.e., every single sequence ends up in 1. Okay, and I thought it was really nice that Dommy actually specified that in the comments. Really nice comments, by the way. And I also, you know, there's in terms of does this look nice? It does. I mean, we've got different run variants here. I mean, the run variant, it just reminds me of sort of ABAP programming and variants and so on, just different variations. But I think, yeah, I think it's quite a nice layout. You know, obviously it's a lot more complex than other solutions because actually it's 3 different solutions in one submission. Okay, rather than 3 different submissions, 3 different solutions. So really nice. And of course, we know hopefully that the answer that we're all looking for, what is the starting number with the longest chain of terms, longest sequence of terms? That number is 837,799. Okay, so yeah, well done to Dommy first of all for pointing out explicitly that yeah, this is basically dependent on the Collatz conjecture being correct. Hey, Huseyin, welcome, and Alessandro and Heiko, welcome, welcome, welcome. This is great. So that's one of the ones to to highlight here. Now, by the way, what I'm going to be doing probably this time next week, I'm going to be publishing a blog post with all the ones that we're going to be talking about here listed, and from these 19 or 20, however many there are, these are all sort of candidates. I'll be also in identifying, you know, a small handful of finalists that then you, the community, will be able to vote on. We'll do that in the same way that we did that last time. I'll put the post in a coffee corner. I'll put the list of, you know, the small list in the coffee corner. So my brain is completely dead today. I've had even a third coffee. It was a long weekend, actually. Fantastic, a successful weekend. Kudos to all the SAP Online Track organizers for doing such an amazing event. They must be exhausted because I'm exhausted. Anyway, so yeah, I'll put together a coffee corner post with the finalists as well as a blog post listing all the ones I'm talking about here. And then we can do the voting procedure to vote on the winner. of the the reduced shortlist. Anyway, that's dummies. Okay. Now what I want to do is to start digging into some of the other solutions. Now, the very first solution that was submitted on the 27th of April, actually. Hey, Oliver. Hey. Welcome. Was from Alexander Frank. Here. And let's have a look at, here we go. And he also references an optimization, okay, which is really nice. Well, the optimization is described or mentioned by Professor David Eisenbud here in this wonderful number file video on the collapse conjecture. I'm just going to post a link to the number file video there. I'll leave you to watch that video. It's only 7-8 minutes long. And Alex has also submitted his solution in the form of a Replit instance, which is really nice. I mean, Replit is awesome. I've been using Replit for code at home, and it's really, really nice. So basically, Alex has a number of optimizations, first of all. Not that this is all about optimizations. Oh, yes, talking of optimizations. One thing I did do is I as many as I could, basically any code that I could grab and convert to run locally in Node.js, I did, and I've ended up with a little private project here with all the submissions I could do there. By the way, there I did do my own, which is this one here, which pales into insignificance when compared to your awesome solutions. But basically, what I also did was a little performance test, performance test mechanism, just to test the performance. Not that performance was by any means, a core feature of, winning candidates or anything. So let's actually let's just do performance tests of each one as well. It's quite cool to sort of look and compare how each does. I'll performance test mine as well, actually. I'm using a really, really nice performance testing mechanism, which I'll show you shortly. To do this, you can sort of run the code that you want to performance test a few times, and then it will run it 10 times and take the average. So in fact, I think this one here. Come on! What's going on? There we go. So this is also, of course, let's just bring that here. Local project CC2. Let's have a look at, where is it? This one here. Yeah, so don't forget, this is performance testing actually 3 solutions at once. Okay, so that's a little bit unfair to do that to dummy. But basically, the performance test. So what we're looking at here is the sort of the mean time in milliseconds. 3,000 milliseconds. And the performance test is using this thing called Hyperfine, which is absolutely awesome. So have a look at Hyperfine if you're interested in doing sort of some terminal-based performance testing, which is really nice. So let's do a performance test on Alexander. What was it? Alexander Frank. I think it's pretty damn fast, this one. We've got a 283 milliseconds performance for Alexander Frank's submission. So let's have a look at it. It's got a number of optimizations. He is using this sort of a buffer for the chain length, which is a pre-filled array, an unsigned integer 32 array, which I've seen a number of you use, and that's it gives you a really nice performance gain when you're sort of pre-filling and pre-structuring something to store lots of information in, like we're doing here with all the different lengths of chains for all the different starting numbers. So that was really nice. The other really cool thing that I noticed that Alexander did here was that what we need to do, in fact, if I show you my solution, not that mine is any sort of standard to judge anyone's by, but if you look at my solution, I was using I'll change it now. I was using originally the modulo. Okay, so we can't see that now. I was using the modulo. It's also I guess we should do a performance test of mine as well, right? To show that it's not great. but I was using modular arithmetic to test whether a number was even or not. But actually, and I've tested this myself, if you use the bitwise AND operator, you can then check, of course, if you bitwise AND it with 1, 0, 0, 0, 0, 0, 0, 0, 1, you can easily test whether a number is even or not, right? Okay, because obviously the least significant digit is going to be 0 if it's an even number. So that's a really nice and faster test to test whether a number is even or odd, or to test whether a number is odd, right? So that's a nice little optimization. Plus, what was described in this video here by, what's his name again, Professor Eisenbud, I'll close that now, is that basically what Alexander does here. You can do odd and then even without checking odd or even in between. So because basically that's, if you multiply an odd number with an odd number, you get an odd number, right? So basically when you add 1, it goes straight to even. So if you get an odd number, you can actually skip one of the checks. And that's a really nice little optimization. So that's the reason I want to show this one. Yes, exactly, Mahesh. Dominic, that's what I was saying before. I think you must have said that at the same time. Dominic says he's got 3 solutions, and that's why it took 3,000 milliseconds. No problem at all. But again, let me stress, performance is not by any means any of my top 5 criteria. It's just feel. It's just is this nice? Does it look nice? Does it feel nice? Can I read it? Can I understand it? Comments, white space, all that sort of stuff as well. So, and the other reason I wanted to show you Alex's solution is that it inspired another solution that came along right at the last moment from Marcelo Urbani, okay, which we'll look at later on. Okay, so this is the wonderful thing about this coding solution to me, that other people's solutions can inspire new solutions. So that was that one there. Okay, so let's have a look at the next one. The next one in my list is from Deepak, and I think Deepak, did I see you on the call as well? I'm pretty sure, yes, Deepak. Hello there. So this is Deepak, and Deepak submitted how many? I think you submitted three solutions, which was really nice. And in fact, I want to highlight these different 3 solutions for lots of different reasons. So first of all, this is a really nice integration of UI5. Okay, so the solution is in UI5, which is really nice. So let's try that again. We start processing there. Really nice. So 1 million, start processing, bang, 837,799. So I really like that. And also it's using JS Fiddle, different to REPL. Not that it's better, not that it's worse, but I really like that. And also in JS Fiddle, there was a nice technique, nothing to do with the JavaScript solution, the nice technique of using a script tag to embed an XML view. This is something I've been doing for a long time, and I really like that approach that HTML offers us to give us the ability to have sort of embedded XML views in the document. So I thought that was really nice. A nice complete solution. So well done, Deepak, for that one. What else have we got here? Oh, yes. Here we go. Let's have a look at this one. So this is a solution from Moritz on his bike there, which is quite nice. A good picture. And what was this one about? I've got my notes over here. Yeah, the really interesting thing about this one, I really like the fact that, unlike all of my usage of Replit, this is a solution that comes with its own license, which is really nice. MIT license, copyright Moritz, and also a README, which, points to the coding challenge. We've got also, some sort of nice configuration there for Replit, but, the main thing, what we're really interested in is the solution here itself, right? So, yeah, this was one of the few solutions that I saw that had a use strict. Now, there's a similar thing that that Perl has as well, but I sort of almost like forgotten about use strict in JavaScript. So it's a literal string that causes different warnings and different restrictions to be placed on your code. So basically, you become a better coder by it. But in general, I think it's a nice solution. One thing I think that was missing was there's no comments. So but I think that that sort of is made up for by the use of use strict. And also, one thing that really stood out to me was the fact that there's a use of basically an object, collapse object, to sort of encapsulate all the different variables here, all the different variables, start, end, solution, so on, which is sort of quite nice as well. Yeah, I think that's really nice. This one was quite slow, but again, like I say, let's just try that one. Did we do the other as well, Moritz? Let's do Moritz as well. Did we do a performance test of the other ones? I can't remember. Like I say, my brain is absolutely mush today. So help me out here if I've forgotten anything. So it's performing the warm-up runs. While we're performing the warm-up runs, let me just remind myself of what we also looked. Oh no, we've done. I think we did Deepak, didn't we? We can run. Oh, well, maybe Deepak 5.1. Okay, let's do that one as well. Let's go into here. Performance test Deepak 5.1. See how Deepak's first solution performed. Okay, yeah, under 1,000. That's plenty good enough. 585, very nice. Okay, so we're still doing the warm up on the Moritz ones, which is fine. You know, performance isn't everything. Let's have a look. Yeah, okay, well, let's leave that going and see. What else did we see here? Count sequences defined and used recursively. Yes, so recursion featured a lot in many of your solutions, which is really nice to see. You know, recursion doesn't have to exist purely within the context of, you know, a more functional oriented approach. So it's nice to see recursion. It's almost like, you know, this sort of collapse sequence thing lends itself quite nicely, I think, to you know, a recursive approach. Not that the recursive approach is the, you know, the best approach, but, you know, I think it looks quite nice. So here, this is where I saw. This is what I was meaning when I was using. We were using the modulo arithmetic to work out whether a number was even or not. That's fine here. Some explicit checking of whether the number is 1 or not 1, which is interesting. Yeah. Okay. Let's leave that one there and open Santos. Yes, Santos Kleber. Open all. There we go. So this is Santos. Where's your picture, Santos? Am I missing something? So anyway, what have we got for Santos? And by the way, let's just have a quick look again at. Still running, Moritz. 43,000. Again, not anything to be ashamed about. Oh yes, that's right. So we've got another JS Fiddle based submission, this time not using UI5, which is fine. And the reason I wanted to highlight this one is because it's got a lot of juicy UI5 ES6 features. So we've got, you know, the REST operator here, which is a really nice feature of ES6. This is from JavaScript 2015, but it's, you know, you still don't see it that often in the wild within at least, you know, the SAP development community. So it's nice to see it here. So basically, ... is actually, you know, it's two operators combined into one. It's called the REST spread operator, and used in different contexts, it does different things. And here, it's basically saying, well, however many arguments there are left after, you know, specifying some initial arguments, I want to capture everything in an args array. Okay, so yeah, definitely. Let's just look at that JavaScript REST spread operator. Spread syntax. There we go. Yeah, spread operator and REST parameters. There's another blog post. There's a blog post from Medium there as well. But my religion prevents me from sharing Medium posts because it's a terrible website. There we go. Okay, so there's the spread syntax. So have a look at that as well. Hello, Sumit. Hello, Code Freaks. Hello to you too. So yeah, some really nice ES6 features. N-in, that's another ES6 feature that was introduced in 2015. And we've got here, what else have we got? Yeah, we've got this memoize function that is using to actually memoize something. This is almost like a generic way of memoizing, another function, which is really nice. Okay, so that's pretty cool. Yeah, that works really nicely for me. Again, though, missing comments, and also I don't know whether I do this as well, but I don't know why it just feels so odd to me that we've got let here and we've got var here. Is that deliberate, or is that just, like in my case, just an oversight? So yeah, I mean, really, really nice use of ES6 features there. Well done, Santos. So there we go. That's that. Let's have a quick look at the. We're still performance testing Moritz's one. Let's just go across to here. Let's do performance test for this one, and let's just go Santos. Let's have a look to see how Santos does. Oh, yeah, okay. Performing warm-up runs. It's funny actually, because I feel as though I'm rushing through this because I've only got an hour, but I've got potentially, if I wanted to, more than an hour, right? So Santos, yeah, let's see how this goes. And also, I've just realised that live streaming does stress this MacBook Pro out pretty much anyway, and now I'm stressing it out even more by doing performance testing with Node. In fact, let's have a look at the performance. Oh my goodness me, load average 32. Yeah, MacBooks are not great at multimedia, despite what you think of Apple. But anyway, a better machine will perform better, I'm sure. So there we go. We've got 4,000 milliseconds average for Santos. That's pretty cool. So yeah, well done, Santos. Okay, so we've got a submission, a third submission. So you can see the naming convention here that I used. I used the SAP community identifier and then a sequential number to sort of divide up these different things here. And yeah, Christian submitted 3 solutions in total, which is really nice to see. There's Christian, very nice picture. And this particular one here, I think all the solutions were in Replit. This one really caught my eye. Let's run it, and while we're talking about it, it really caught my eye because it uses one of my favorite libraries for JavaScript. So first of all, I don't think we've seen any library usage, external library uses in the submissions I've shown so far. Not that it's a good or bad thing, it's just a thing. But Christian is using Ramda, which is one of the better functional programming libraries for JavaScript. I'm a big fan of Ramda, and it introduces a ton of functions that you can use within the context of your code. A lot of these functions, are taken directly from the lineage that includes Haskell and OCaml and so on. So if you're interested in learning more about functional programming, I would definitely recommend you look at Ramda. So I'm going to copy Ramda there. So well done to Christian for using Ramda. Now let's have a quick look at some of the functions that Christian has been using. I mean, I have been looking at Ramda-based JavaScript for a long time. So to me, despite not having any comments, again, here, this solution looks really clean to me. I mean, basically, as you can see as well, everything is a function. Okay, apart from the bit at the bottom here, which is, there's a style of coding which is quite pervasive, I think. I always tend to call it sort of Python style because, I started programming in Python. You define all your functions and your classes and everything at the top, and then at the bottom you'd say if name equals main, then go and do this, which involves calling some of the stuff that's at the top. So you predefine everything here, like many of the solutions are doing as well, and then you make the call. So we've got here, we've got all sorts of different things, and you can see that Christian is using the standard sort of paradigm of introducing functions from Ramda. It's a capital R, which is the de facto standard library name for when you bring in Ramda. And we've got, for example, the use of complement. We've got the use of cond. We've got the use of memoize with. So basically, in the previous submission we just saw, we saw a handwritten memoize function. But here, of course, you get memoize out of the box. We got R equals, we got always, we got pipe, we got range, we got map, we got reduce, we got map by. So you can almost say that Ramda is an extra language layer over the top of JavaScript. And I don't know either you like it or you don't, but I really like it. Something really, some really simple example here. If you've got a function called isEven, okay, and that is a predicate function, as in a function that returns true or false, then you can use complement to flip that predicate function. You pass that function to is complement to order complement, and then whatever isEven gives, it gives the opposite. So that's how you can define isOdd as not isEven. Cond is, of course, a condition thing where you say, if this is true, then do that. If this is true, then otherwise. If this is true, then do that. So it's like a switch statement type thing. And I think it results in a really, really nice, clean looking code base. We've got pipe as well. Anyway, if we looked at all the details of all these different solutions here, would be here all day. So I'm not going to look at that. In fact, let's just performance test that one. Performance test. What was it? Drum 3. In the meantime, okay. So Moritz, 42,000 milliseconds. Okay, it's a solution. It works. That's pretty cool. Yes, I think. Yes, of course. I'll come back to that. I think it's because I've not installed Ramda. Did I not go into there? Submissions, Christian, Ram 3. It's all my fault. Node index.js. Did I not install it? Okay, we'll try that. Anyway, sorry about that, Christian. Okay, so let's move on to the next one. And the next one is also from Deepak. Deepak's second solution. And why did I want to show Deepak's second solution? Leave site. Yes, because he wrote a really nice post. I mean, some folks like Deepak and many others, really sort of enjoyed or seem to enjoy going to town on this and really digging in. So he presented another approach in JavaScript, but then sort of breaking the rules a little bit, sort of in a nice way. I mean, who is complaining here? Submitted a solution in ABAP. So if anybody would like to try that in Steampunk, then there's the code there. Moreover, not only did he submit a solution in ABAP, he submitted. Oh, I'm so tired, I can't even speak. He submitted a solution in SQL script for HANA as well. So I thought that was definitely worthy of a mention. Yeah, I think that's pretty cool. So well done to Deepak for that one as well. What else have we got? Oh, Vinay. Yes, here we go. So Vinay used something that I'd never seen used before. I even had to look it up on Stack Overflow. Okay, so this is Vinay. No picture of Vinay. What's going on? Not that you need a picture. So here is, I think this was the first one I saw as a solution supplied via Plunker. I think a few of us back in the day, back in the early UI5 days, we used to use Plunker because it gave us the ability to actually have multiple files. It was better than JSBin in that context. So as you can see here, you've got a proper UI5 based solution, which is really, in fact, let's just run that again, preview. What's going on? Did I not do that right? Let me go back here. Where is it, Vinay? Let me open that again. Yeah, in fact, there's the, where is it? Come on. Yeah, there we go. There's a solution. So let's run it. Get collects length sequence. pretty fast as well. Okay, so really, really nice. Let's have a look at the code. So there's the bootstrap, really cool. And the main actual solution itself is in here. Okay, so yeah, pretty damn nice. Now, what are my notes here? Oh, yes, here we go. There was a use of, where was it? Here. Who's seen this before? Double tilde. Double tilde. I had to look it up. What is the double tilde operator in JavaScript? Basically, it's a double, not bitwise operator. And basically, if you've got a number as a string and you want to convert it to a number, it's a pretty fast way of doing that, basically, which I thought was pretty cool. So yeah, there we go. Let's paste the link to this Stack Overflow post here. Did I mark it? Oh no, I didn't mark it up. There we go. Be a good Stack Overflow citizen. Mark that up there. So yeah, really, really nice comments here. Nice layout. Yeah, I think generally the combination of a proper XML view with a controller inside the Bootstrap UI5. Yeah, really clean. Nice work. Nice work. Did I bring that one into my performance testing? I think I did. Let me have a quick look. PT Vinay S6. Let's try that. Yeah, it's also pretty fast, as we saw from the immediate pop-up of the alert message. 430 milliseconds. Yeah, pretty nice. Let's just do that later, I think. Okay, so who's the next one? Final one from Deepak. This is crazy, I know. I did. To be honest, I was thinking, shall I show all of these from Deepak? But I think, yeah, definitely worth it. Somebody's going to go to the effort of submitting 1,000,001 solutions. Another one from Deepak. Here's Deepak's face again. And we've got a solution here with with web workers. So that's definitely something I want to show here and to list in the blog post of the sort of these solutions that I'm showing here. I couldn't convert this, of course, to run in Node.js because, of course, there's no concept of web workers that I could get working. But yeah, really, really nice solution. Start processing, bang, 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 in the background. Let's do that as well. Emphasize free thread. And in fact, one of the things that Deepak said here was that having separate web workers was almost like a blessing and a curse at the same time. Yes, it is. That's exactly, Alessandro. That's the first time I also saw double tilde. One of the advantages of web workers is they can go off and work in parallel. But of course, for this sort of solution, enter size for each thread, default 10,000. Let's have 50,000. Start processing. One of the disadvantages for this sort of solution is that, of course, you want to have a shared cache of results. One of the classic optimizations that many of you used here was to cache the results. So you start with 1, then you go 2, 3, 4, 5, 6, and work out the lengths of the chains of terms for each of those starting numbers. And of course, you put the results for each of those into a cache, into an object, for example, or an array, or whatever. And then once you get to the number in that sequence, then you can actually look in the cache and say, oh, there it is. So that's a really nice optimization. But of course, with web workers, you're effectively splitting up the ability or destroying the ability to do that sort of thing, to share that cached information. But nevertheless, I thought it was definitely worth showing that one. By the way, in case you're wondering, of course, I'm going to be putting all the links to all the things that I'm showing here in the blog post I'm going to be publishing next week. So that's that one. So where are we now? Gaurav. Yes, Gaurav. Here we go. Open all 3. Why is there 3 things in there? Oh, yes. Because... where are we? Yeah. First of all, this is Gaurav here. Well done, Gaurav. And this is the first use of CodePen, which is really nice. And let's just... Did I... I'm pretty sure, does this run automatically? I can't remember. I remember seeing the output here. What's going on? Let's just have a quick look. Let's just refresh that, unless I did something by mistake when I was opening it up. What is it open? Well, anyway, while we're waiting, in fact, while we're waiting, let's go across to here, performance testing, and Gaurav Chowdhury. Let's just check to see how that is. It's interesting, actually. The performance measurements that we're seeing today are being influenced by the fact that my machine, I can hear the fan, the CPU fan going crazy because I'm live streaming. So these will be higher than normal, higher than I've actually recorded in my little spreadsheet. So anyway, let's let that run. You would not believe how dead my brain is. I can't even speak. But anyway, let's keep going. Yeah, so one of the things here is that he wrote a really nice post as well. I mean, this is, again, a really nice side effect of these sorts of challenges. I'm looking forward to, being involved in some challenges myself. But yeah, really nice post. And even some beautiful output sort of explaining to you. I'm not going to go through the post right now, but I want to share the post here. There we go. Yeah, I thought really nicely done using Python for this. So the color scheme check. Yeah, okay. Yeah, there we go. He's written the code in Python as well to actually visualize the data, and you can plot 2D graphs in Python pretty easily. Yeah, so beautiful little article there from Gaurav. I'm not sure where the run button. Basically, where's the run button? Am I missing something here? I remember seeing, because it actually showed the individual terms. I can't remember. If anybody can tell me how to kick off something in CodePen, my brain is at a complete blank. So Gaurav, if you're on, let me know. What's this thing here? No, that's the blog post link. Okay, oh well. CSS, JS, how would you run that? Don't know. Okay, anyway. So there's Gaurav's solution. So let's have a look at the next one. Andrew, all the way from Australia. Let's open this. Andrew Barnard. There we go. There he is. Nice picture. And what are my observations? Yeah, I really liked the fact that Andrew basically provided a lot of comments. Let's just run this in Replit. And there was to me, not only did we have a plentiful comments at the start, basically this is reproducing the problem statement, which is always useful for this sort of thing, right? But, plenty of comments here to help me read through, which I thought was really nice. Plus, basically no function is too small to define. I really liked this idea of, no function is too small, too trivial. Check this out here. We've got this is1, okay, which is a function that basically takes a parameter and just returns. It's a predicate function, returns whether that number is 1 or not. Okay, how far is too far when defining functions? I've seen a number of beautiful solutions that have been submitted that are, all functions all over the place. And here's a nice example of that. So we've got the is even, and also this is another style that I've seen. I've seen some folks with, Hungarian notation, which was discussed on the previous coding. Was it previous coding challenge, or was it basically from between between Rich and Tom before the first coding challenge? Yeah, nice discussion on Hungarian notation. And I've seen a number of you submit solutions here with variables, prefix, and constants prefix with with little letters in Hungarian notation style. But one thing I do like, and I don't know whether you would call it Hungarian notation, is the name of the function here beginning with is. Yeah, I suppose it's not Hungarian because it's not saying this is a function like f or something. But when I see a function beginning with is, I automatically know in my mind, okay, that's going to return a true or false. Is this yes or no? Right. Anyway, really nicely laid out solution here. Let's just did we do that here? Performance test, Andrew, Barnard. I'm so conscious of saying Barnard or Bernard. Anyway. In the 2000s, yeah, that's nice. Yeah, a number of you had various optimizations. For example, the use of the bitwise OR for checking whether a number is odd or not. Using a cache, a memoization effectively. I know that memoization is a name given to things that are specific to recursion, but in general, I think you can use a term for just saving stuff to look up, right? 2,500 milliseconds, not bad going at all. But yeah, a number of optimizations. No optimizations here, but 2,500 milliseconds. Yeah, I think we're okay. Let's leave that one. Yeah, I still don't know how to kick off this CodePen one. In fact, if I share this with you folks here, somebody have a play about with it and tell me how to run it. That would be good. Okay, let's go back to Huseyin. Oh, yes, this is a nice one that I remember looking at and enjoying. So Huseyin, I think Huseyin, you're on, right? You're on this live stream right now. There's Huseyin. Oh, there we go. There's Huseyin. Nice, handsome picture there. And we've got, glitch sort of takes a while for things to load. First of all, inactive projects go to sleep and wake up on request, which is fine. So this was the first, and I think possibly the only submission using glitch again. All sorts of different ways of presenting your code online as a runnable thing. And let's see if this wake up. You're on. Perfect. I'm not sure whether there's a feature that you can sort of play around while you're waiting for something to wake up or not. So come on, what's going on? Oh, starting. There we go. Come on, starting. Did I? No, I don't think I did copy this to my Node.js environment because there's 3 different approaches all tied together using web components, UI5 web components. Come on, what's going on with glitch? Let me just refresh that. Come on, glitch. Please play ball, otherwise I'll have to come back. There we go. It might have been me. Okay, so just like other folks submissions, we've got a nice UI here, but this particularly struck me because it uses, and Huseyin, let us know a little bit more if you can in the comments. This used web components, UI5 web components. Really good looking UI. Here's the basic information with the sort of the rules here, even and odd and everything. Let's collapse that. Let's test a number. That's that 13 in the example. Where is 13? That 13 had 10, right? Come on, DJ, brain, wake up. 13 had 10 terms, so that's a nice little test. 13, 10 steps required. It's pretty fast as well, right? And we've got 3 approaches. First approach, let's just use the first approach for now. Find the product producer of the longest chain. Nice little weight thing there. I can't even think of the name for that either. I think I need to go to sleep after this. 837799, really nice. Second approach, let's run that as well. And the things as well are described very nicely in the project itself. So yeah, really impressive solution. I think glitch may be running a little bit slow today. Yeah, so really, really impressive solution here with the problem definition, the blog post, his profile, going to the app, and the details of the solution as well. So yeah, great work, Huseyin. I really like that one. That one. Okay, so we've got Raul. I think I saw Raul as well on the live stream chat. Did I see Raul? Huseyin. Yes, UI5 web components with parcel bundler. Excellent. Okay, so here is Raul, member since 2016, although I never know what that member since actually means. Here we go. What did we have to note about Raul? Oh, yes. So this particular one here, and this is really something I wanted to point out for future submissions. So Raul, as you can see from where is it? As you can see from the link here, Raul Ruiz Gomez 2, this is the second submission from Raul. The first submission was a little bit slower. The second submission was pretty fast. So let's have a look. Performance test, Raul Gomez 2. Okay, let's keep going. And this is, okay, 2,600 milliseconds, but this is a lot faster than Raul's initial attempt. So, really what I want to point out here is that, again, like I say, performance isn't everything at all, but also, have multiple goes. There's that coding, a bit of philosophy, write the first version to throw away. And maybe that's what Raul did effectively. A really nice improvement on the sequence. So yeah, well done, Raul. Again, it's a ton of things. I'm not sure. Let me know whether. Oh, you are there. Fantastic. Let me know whether this sort of approach to reviewing solutions it works for you, or whether you would prefer just like maybe one or two solutions, but do a deep dive into some of those to really understand how they work. I'd be open to suggestions, not just for this particular coding challenge, but for future coding challenges as well, because we intend to do more coding challenges over the next few weeks and months. So we would love your feedback. Hey Fink. We would love your feedback as to how you would best like to enjoy these sort of live stream reviews. So yeah, really nice from Raul as an improved approach. This was version 3. Yeah. Anyway. Here we go. So now, where are we? Thales. Thales Batista. Here we go. What did we have to say for Thales? There he is. Nice photo of Thales. Oh yes, I didn't manage to measure this locally because, first of all, multiple implementations. Secondly, and a slight rule break, as it were, because one of those multiple solutions wasn't actually in JavaScript. It was in C. I mean, this is pretty interesting. We've got web workers, and we've also got WebAssembly, which is something that may interest many of you here. So here's a Collatz solution written in C, but compiled to WebAssembly. If we run this now, let's run the whole thing. I think that Replit is noticing that I'm running a lot of these things at the moment, and it keeps asking me, do I want to upgrade? So maybe I do need to upgrade. So yeah, this was, I mean, to be honest, I would like to pretend to understand how this was built, but to be honest, I don't. This is super educational. Definitely worth looking into. There's multiple solutions here. There's the WebAssembly one. There's web worker based. Yeah, nice educational piece of work here from Thales. There we go. So we got the synchronous one, giving the right answer, the functional one, and also the WebAssembly one. Yeah, really well done to Thales on that. So we got the required. This is also a way. This is also a good example of seeing how powerful Replit is for seemingly complex solutions with multiple files and modules and web workers and packages. It's a lot more capable than one might think. So there is Thales' solution. So let's just get rid of those there and bring in, what's the next one? Kadir. Ah, yes, Kadir Özgür. Let's have a look to see what I said about Kadir. Ah, yes. So Kadir is here. Again, no, why do you folks not have many pictures? Only some of you got some pictures on your SAP community profile. It'd be nice to be able to see you in person, as it were. But anyway, so come on, Replit. Yeah, I think what took my eye about this one is, again, it used a couple of libraries. We got the maths library, and it was using the maths library for very, very narrow purpose. It was quite nice. If I just look for maths, say, yeah, we're using mathlib.max. Okay, so yeah, why not? Rather than write your own sort of max, it's using max from a maths library. But also Yosei. Anybody who's used any of the command line build tools in the UI5 or JavaScript area generally over the past few years will recognize this sort of yeoman way of putting out a message, which is quite nice. The one thing that I wanted to point out here was this really interesting use of array.from. Okay, so one of the things I think JavaScript is lacking is a native ability, a natural ability to generate a sequence of numbers. And you've got, what Kadir is doing here is he's instantiating an array of, of a certain size, X here. But then he's using array from on that, and array from, basically, why don't we have a look, mdn array.from. Yeah, the array.from method creates a new shallow copied array instance from an array-like or iterable object, okay? And what you do, or what you can pass, is a map function, effectively, okay? That's going to be called on every element of the array. So that's why we've got a little function here that he calls his create chain here. And the interesting thing is, in terms of style, this is something you'll see quite a lot, again, in more functionally oriented languages, where functions are important and therefore where sometimes parameters are not important. The function defined here, as we can see from the where are we? The map function. Where is it? I can't find it. The array-like object map function, the map function to call on every element of the array. Ah, yes, okay. So the map function, I think the reason it's called map function is because it's a function that would normally be called within map. And when you call a function in map, or when map invokes that function, it passes each time the element, but then also as a second parameter, it passes the position of that element in the array. And that's what I think Kadir is doing here, i.e., I don't care about the actual value of the element in question, but I care about its position, X, okay? And then it goes and calls its create chain for that given number. So it's a nice way of generating an array of numbers. So there we go, that's that. So what else have we got here? Oh yes, did we do this one? Do performance for Kadir, performance test. Kadir, let's just see how that goes. Okay, 6,000 current estimate. Let's come back to that. In the meantime, let's bring in Mahesh. Mahesh, you're on the call, right? You're on the live stream right now, I think. Are you there, Mahesh? There he is. Nice picture where the tech gets real. And in this particular submission, the tech for Mahesh got very real, or rather the learning got super real. I mean, this is something that caused me to go outside when I first saw this with a cup of coffee and learn or relearn about trampolines. So Mahesh's submission here, where are we? Let's just see that again. Mahesh's submission here is part of his learning journey that he told us about on the actual submission email into functional programming, and what a journey Mahesh is on. So we've got this idea that Mahesh is using of trampolines. So let's put the post in there, put the link in there right now. It's a really nice article about trampolines, and also the references to the Wikipedia pages for each of these different concepts in functional programming. They're not just, it's not just functional programming that these concepts live within. But anyway, a thunk, continuation passing style, tail recursion, these are all super important things to understand if you want to, you know, move ahead in your learning journey about functional programming. Recursion, C recursion, very nice, I just noticed that. So yeah, a really, really nice way to explore, you know, the next level of features. Now, this may be something we want to look into a little bit more, or maybe we'll get Mahesh on to show us this, or maybe Mahesh, you want to do a live stream about this. I would love to learn more from you about this, but I think this was fantastic. So let's run this, by the way. Let's come back to there. Okay, yeah, Kadir has finished. 8.5 thousand milliseconds. Again, bear in mind that are we still thrashing this machine? Low average has gone down to 11. Okay, still pretty crazy. But anyway, performance tests. Let's just run that here. I think this one. Oh, I think Mahesh, you win the prize as the longest name here. The calculation for my Figlet and lolcat was a little bit wrong here. But anyway, let's have a look. So yeah, absolutely fantastic submission from Mahesh here. It really shows that. For me, the real spirit of these coding challenges is about improving one's knowledge, or increasing one's knowledge. So this is fantastic, because I know, Mahesh, you've been on this journey, right? Okay, so don't performance test mine. It will take 5 minutes. Okay, let's cancel that for now then. The current estimate is around 15 seconds. That's fine. I think a little bit over there with your 5-minute estimate, but yeah, well done to Mahesh for this trampoline-based solution. Yeah, dig into trampolines when you get a chance. Oh, here's a nice solution from Tom. This is a really nice presentation, if I seem to remember. There's Tom. Oh, this top-level menu is really getting on my nerves at the moment. So here's Tom. And his solution is in JS Fiddle, another one in JS Fiddle. And yeah, one thing I really liked about this solution is it's got a super amount of comments. And again, while there are no comments in the actual code itself, that's okay. Okay, there are here. There are plenty here that explains what's going on. And if Tom is on, I can't see, I'm so tired, I can't even highlight something properly. If Tom is on, let us know what your thoughts are relating to this. Avoided memoization, since that would require recursion. I mean, are you referring to the fact that, yeah, memoization as a specific term only actually relates to recursion? But yeah, really nice bit of code here. 837799, nice solution here. Yeah, really nice presentation, nice layout. Yeah, generally, I really like that. A lot of stuff that was sort of explicitly and deliberately demonstrated and also commented. For example, IIFE immediately invoked functional expression. For the reusable part, is using an imperative part for the actual solution, and a little bit a dash of functional programming to update the cache. So yeah, again, another aspect I think is really important for these coding challenges is to explore different approaches and different styles, even within the same program, as well as, of course, what I mentioned right at the start. We're going to come to that right at the end, actually, where we had Marcel sort of be inspired by Alexander. So there's a nice solution from Tom. What else have we got here? Oh yes, in fact, here we are now with Marcel Urbani. Let's open those. So there's Marcel, and a nice photo. And there we've got one of a number of solutions submitted by Marcel. He wrote a really nice blog post, or not blog post, a Coffee Corner post in the Coffee Corner. Here we go. Here it is. And he submitted a number of solutions, and his favorite is the functional one, which is this one basically. It's a mutable one, which I think is one of my favorites in terms of the way it looks. I mean, I would like to, if I wrote a solution, I'd like it to look like that personally. Maybe I'll add some comments or something, but really nice use of the classic sort of map reduce. What comments did I put here? Yeah, no, but this is, we got the next collapse. Okay, there's not really not really anything to say about that. We've seen this a lot. We've got a simple function that takes a number and gives the next in the sequence. That's used inside this recursive collapse length function. Again, lots of really nice short functions here. Another really nice way of generating numbers. So we've got the rest operator here, using the array instantiation of n+1. Let's say n is 999 or whatever. Getting the keys of that and then slicing to say, well, let's go one forward. So instead of 0, 1, 2, 3, it's at 1, 2, 3, 4, etc. Yeah, really nice way of generating natural numbers. Let's run that. And then what I just really like the idea that map reduce is a natural way to come up with this. We start with the natural numbers. We map over those natural numbers and work out the length using this recursive solution, and then basically use reduce to work out what the longest one is. So yeah, really nice. But that's not the one that I wanted to point out. Here we go. There's a comment from Marcelo here at the bottom. This is my fastest, shamelessly inspired. There's nothing shameless if you refer to what inspired you by Alexander Frank's solution. So this is the one that's Marcelo is referring to, the one we looked at right at the start. Okay, optimized solution with the unsigned integer array here and with the bitwise test for odd number. Okay, and also in fact with the with that sort of skipping a step. If it's an odd number, you can skip through the even to the next odd. Anyway, so this is a nice solution from Marcelo, and in fact, let's run this performance test of this one. Performance test Marcelo. Oh yes, it's Urbani, isn't it? There we go. Urbani 3. There we go. 129 milliseconds, pretty fast. Last time I ran that, it gave me 66 milliseconds, which I think is one of the fastest ones. A small collection of really fast ones, like under 100. Again, because my machine is thrashing at the moment, it's not going to achieve quite that performance measurement, but pretty damn impressive. So well done, Marcelo, and also well done for giving a nod to the inspiration, and also well done for submitting multiple solutions. So the final one that I want to point out, and there's so many. Again, one of the things I feel bad about is not showing every one. And also not doing, I don't feel as though I'm doing justice to all the ones I'm showing even now. But the final one I want to show is from Frank Schuler. And, Frank is a long-time member of the community, like many of us here. And he submitted a solution that I couldn't sort of reproduce locally because, yes, it was using JavaScript. It was not breaking any rules, but it was within the context of SAP Data Intelligence. So definitely worth having a read of that, because I learnt sort of almost like indirectly a lot about data intelligence, because I didn't really know anything about data intelligence apart from the stuff that I've learned from my colleague Vitaly. I learned a lot from how it works just by looking at Frank Schuler's post. So yeah, well done to Frank, well done to everybody, in fact, for getting those solutions in. Over, well, nearly 80, in fact. Oh gosh, Oliver, hi. Gaurav's CodePen. There was a feature of CodePen that will kill long-running loops. Need to add Windows. Ooh. Shall we try that? That's really cool. So there's Gaurav's CodePen. Let's bring that in. Oh, sorry, that was the blog post. There we go. There. Just a moment. Checking your browser before accessing. What? So you're saying put it here. Can I edit this post? Hey, can I edit this post? Right. Okay. I'm going to cut and paste what Ollie has put in here. That would be amazing. Here we go. We'll see what happens. Okay. Now, waiting for CodePen. Is it doing anything now? Do I need to refresh? And if I refresh, is that going to give me a version? Do I need to sign up? Oh, there we go. Amazing. Ollie, what a superstar. Thank you very much for that. So, yes, I knew I'd seen this before. And this is probably because, again, my machine is thrashing. But, yes, of course, this gives you all the different terms. So 837799 is the first term in this sequence, and it's the longest one as well. There's 85. So I thought that's a really nice solution. Also, a really nice visualization of what these term sequences actually look like. So, yeah, well done, Gaurav, and well done, Ollie. So there we go. So congratulations to everyone who has submitted, because it's the taking part. I think out of the 78, 79, almost 80 solutions, let me just check. We only had, let's go across here in my spreadsheet. We had fewer than 10 submissions that were a fail, as in didn't produce the right answer. All the ones that were submitted, though, even the ones that failed, will be listed in the blog post. I'll highlight the ones that we've gone through today in the blog post with pointers to extra bits and pieces, and then I'll write a Coffee Corner post with 4 or 5 of those I've highlighted today as the finalists. We've already identified who those are. So you've seen the finalists already today, 4 or 5 that we've seen already of those. Oh my goodness, my brain is so dead. And that will be after the blog post, and then we'll have a voting period. We'll leave that open for a while, and then we'll announce the winner, who shall receive the fabulous, as described by Tom Young, the fabulous No Prize. Kudos. Okay, so that's it. Thank you so much for being a part of this, submitting your solutions, amazing my brain and my colleagues' brains with all these wonderful bits of code, for exploring, new avenues of learning and everything. It's been really good. So this is exactly what these coding competitions are all about. It's not about being the fastest or by being the neatest or anything really. It's about exploring for yourself and learning from each other. So with that, I'm going to end this live stream. Thank you so much. Next live stream from me is going to be on Wednesday afternoon, same time as in 2 p.m. Manchester time. I've got Marius Obert on, my colleague Marius. He's going to be doing some really cool UI5 stuff. And then, of course, I've got a normal live stream on Friday. Normal time, normal place. So, yeah, thanks so much. And I'll see you all online on this live stream on Wednesday. Bye for now.